sessions will have an A and a B at the end of them today, because there'll be two of them.
Okay.
So number 2, what's the initial value?
So, it was 1250 e to the negative.
The initial value is always that first number.
So 12 or
that was the equivalent of the 5,000 in the previous problem. Whatever that's a sub 0. Okay?
okay.
Is that equation growth or decay? It's real easy, whether it's positive exponent or a negative one.
So decay.
At what rate is it decaying? Remember, the number in front of t is r.
Oh, so or by 60%?
Correct. And it's correct not to say negative 60. You could either say it's growing at negative 60% or it's decaying at 60%. The negative sign indicates decay.
Okay.
Number 3, what's the initial value?
450.
Is this growth or decay?
Growth.
What is the rate of growth?
12.
Nope.
Or
It's the number on top. It's the numerator. That's r.
Oh. So 8.5%.
Correct. How many times a year is it being compounded?
12.
Okay.
Times it.
Number 4. What's the initial?
12 or
Yep.
Yeah, 12.
Is it growth or decay?
Growth.
What's the rate of growth? Decimal does that fraction equal to?
1.4. So 14%.
40%.
Yeah.
Okay. Number 5. I know you know the first question is number 5, growth or decay?
Growth.
What's the rate of growth?
Yeah. Okay. So, is it 83%?
Correct. Number 6. What is the growth or decay?
So
if this number right here, 2.75, if that number is greater than 1, it's growth. Less than 1, it's decay. Okay?
Okay.
That's growth. What's the rate of growth?
By 10%.
How much? Remember, you got to subtract 1 from that number in the parentheses.
So
you're looking at 1.75. What percent is 1.75?
175%?
Correct. That could be like bacteria in a petri dish that would be growing really, really fast. Okay. Number 7. Growth or decay?
Decay.
Rate of decay?
By 20%.
Okay, number 8. Growth or decay? Notice that even when it is not in an equation, you can still figure out if this thing is going to grow or whether it's going to decay as x gets bigger. In other words, when I put in x of 1, I get e to the 12th. When I put in an x of 2, I get e to the 24th. So as x gets bigger, this whole thing definitely gets bigger. That means growth. Same thing with the one above it. Neither one of them are part of the equation, but you can still figure out growth and decay from it. Okay, number 9. What's the initial value?
0.12.
12 cents. That was in dollars. Growth or decay? Remember what I said about number 6. If that number is greater than 1, it's growth. If it's less than 1, it's decay.
It's decay.
Okay, what's the rate of decay? That's 1 minus r is what that number is. It's 1 minus r. So what does r have to be?
Negative 11, so 11%?
11. You wouldn't say negative. In other words, the formula is the following. The formula is, when you have decay, the formula is 1 minus r in the parentheses to the t power. So in this case, r has to be a positive 0.11, so that it would be 1 minus 0.11, that's equal to 0.89. So r is 11%. It's just decaying 11% per year.
Right, yeah.
All right. Wow, even Bitcoin questions. I've been tutoring for 9 years now, and first question I've ever seen that is with the new terminology of our culture. Bitcoin. That's pretty cool, actually. At least they're keeping with the times, including the interest rates that they're putting up here.
Yeah.
Okay, so he invested his life savings in $26,000 in Bitcoin. Let's hope he didn't do it 2 months ago, because now he's only got 13,000. But okay, so the day after he does this, value of Bitcoin crashes, it loses 12% of its value every hour. How much will his investment be worth after 6 hours? So this is basically this equation. And let me explain why. Where R is in his rate, his losing rate per hour, and T is the number of hours. Okay, so it's pretty much you use this is hopefully not going to be too confusing, but you use the annual compounding or decay. This should say annual compounding or decay. And when it's decay, it's 1 minus r. And even though this isn't annual, notice that if I change that to year and this to year, then I would use this formula exactly. So the fact that it's hour instead of years, I'm still going to use this exact same formula.
Okay.
Okay, that's a little hard to understand, but take it from me, that's what you have to do. So your amount is, fill in everything for me.
So A equals 26,000 times 1 minus 0.12, right?
Uh-huh.
And then 6.
To the just the 6. Remember that T is in hours. T can be in lots of different time frames. T can be in seconds, minutes, hours, days, months, years. But what it is it has to match whatever the time frame of R is. In other words, R is every hour, so T is in hours. Now do that, and you're going to come up with a shocking conclusion. Take 0.88, take it to the 6th power, and multiply it by 26,000.
So it's 12,074.50.
And that was in 6 hours. And you know what? These numbers are not that far off. I've seen Bitcoin move at that kind of a rate, at 12% per hour for 6 hours, and lose half its value in one day. That's how volatile that is.
Yeah.
All right. So let's look at number 11. Oh, this is going to be a good investment because it's called College Invest. Okay, for his new baby girl. Interest rate of the plan is 5.6% compounded continuously. So if we're going to underline key stuff here, we're going to underline those 3 things. And that. The newborn girl, so here's, what's the general for continuous compounding?
A equals P.
Okay. Hurt.
E. Yeah. E raised to the RT.
Okay.
R times.
Now fill in everything.
So A equals 1450 or yeah.
500.
500, yeah. And then times E. And then to the 0.056 times 18.
Uh-huh.
Okay.
Now let's think about that for a second. On her 18th birthday, how many years will that be? Let's see. On your first birthday, you've been around for 1 year. So on your 18th birthday, you've been around exactly 18 years. So yeah, this would have had a chance to compound for 18 full complete years. Okay.
Okay.
Now what's that number? And then multiply it by 14.5. And they're going to show us an intelligent investment as opposed to Bitcoin. Being facetious, I used to own Bitcoin. Unfortunately, used to is the key phrase.
Yeah.
4 years ago when it was worth $200 and now 20,000.
So what? Hold on. So E
Should be a pretty big number.
0.08
Should be around 70 or 80,000.
and times
More than that, probably.
14,500. Yeah, okay, so it's really big number.
How big?
345 million?
No.
I don't think that's right.
Do this first. What do you get? Well, actually,
So,
do this first. Multiply 18 by that number, and then take E to that answer, and then take that answer, multiply it by 14,500.
oh, that's something I got different. Okay, that's weird. Okay, so then E to the 1.008.
Yeah, that sounds right. Yeah.
Okay, and then that times 14.
2.7, so this is going to increase by about 3. Not even that.
So 39,731.
Yeah. That's nice. Not as big as I thought it was going to be. Because 18 years is a long time. I mean,
Yeah.
Bitcoin would have done that in 2 days. Seriously. But it would also do number 10 in 6 hours.
Yeah.
All right. You got any others, or you want to call it a day?
That's it.
Okay.
It ended early, plus that like 5 minute.
What's that?
We ended early, plus the 5 minute delay. So
Yes.
it's surprising.
Yes, I will take that into account. Okay?
Yep.
All right.
All right.
Talk to you next Tuesday.
Okay.
Bye-bye.
Bye.